Hello and welcome to Chapter 7. We're looking at 7.1, Greatest Common Factor and Factor by Grouping. We have three objectives: find the greatest common factor of two or more expressions, factor the greatest common factor from a polynomial, and factor by grouping. So let's try to understand the idea of greatest common factor. The shortcut for that is GCF, okay? And what GCF does is, if you read it backwards, factor, then common, then greatest. So let's look at factor. A factor here would mean prime factors, basically. I'll just say prime factors. That means any number you have, just like your LCD setup, any number that you have, you will break it down into prime factors. So for instance, let's take 24, okay? If you break this down into regular factors, you could say 12 and 2, 6 and 4, 8 and 3, it could be anything. So we really don't have the same answer to that question, right? What are the factors? We have different pairs that we offer as factors. But with prime factors, we will all drill it down to the same number of factors, the same exact values itself. So that is why we like to use the prime factors. So what that means is you're going to break these factors further into factors until you arrive at one level where all your numbers are prime, meaning you cannot break them any further, right? Prime numbers are numbers that can be divided by 1 and itself only. So we now have 6 that can be broken down as 2 and 3. 2 and 3 themselves are prime numbers. 4 can be split as 2 and 2. So you've got the prime factors for 24 as 2 times 2 times 2 times 3. I like to arrange them in that order. So it helps me to see if I collected them all. And multiply them out. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So you know that you did collect all of them that multiply back to give you 24. So it is going to be the same case. Say you started with 8 and 3. Okay, 3 is already prime, so we're good there. 8 could be 4 times 2. It's still not done because 4 can be split further as 2 and 2. So to kind of give you the last level here, you can see that we arrive at the same last level, even if you went about with different, if you started out with different factors. I wanted to group that too as well, right? So you have 3 2s and 1 3. So that is the idea with prime factors. So we will always get suitable, correct, same, identical string of factors that are prime for any given number. That's the best part. Any number could be split up like that. Okay. So let's look at the first question. Find the greatest common factor of 27x cubed and 18x power 4. So coming back to GCF, the idea of GCF, now we found the factors, right? In this example, we found factors that were for 24. But when we talk about common factors, you need at least 2 things to consider something that's common, right? To find something common, you need at least 2 things. You can have more than 2. So we have 2 expressions here, and they want us to find what are the common factors for these 2. But that's not the end of the story. They do not want just common factors. They want the greatest of those common factors. That is your GCF. Okay, so let's see how we can arrive at this. So 27x cubed. Okay, we want to split this up by the factors. So 27. Again, this has to be done by the side. Let's see. So 27. Let me split that up. 9 times 3. But 9 can be split further as 3 and 3. So 27 gets this last level of 3 3s as the prime factors. What about x cubed? X cubed can be split up as x times x times x. So I'm going to write this as 3 times 3 times 3 times x times x times x. Okay. We do not want any powers to them because that's how you know you have simplified them and written them out as factors. Then 18x power 4. Let's look at 18 here. 18 splits up as, again, you have plenty of choices. I would like to see this as, let's say, 6 and 3. Okay. 6 splits up as 2 and 3, and that gives us that last level of prime factors. So I have 2, 3, and a 3. So 2 times 3 times 3. And then I have x power 4, so it splits up as 4 x's that are being multiplied. Okay. All right, so now that you have split them up as prime factors, it's time for us to begin to group them. So what we do is we group the common factors. Okay. So we have threes, one set of threes that are common to the two terms, another set of 3, another set of x, x, and x, right? These were common for these two expressions. Now we will count them once for each common one you find, okay? So I'll just say GCF, greatest common factor, is one set of 3 times another set of 3 and 3 sets of x. Okay. So multiply these out, you get 9x power 3, right? 9x cubed. So what this means is 9x cubed is the greatest common factor you can find for 27x cubed and 18x power 4. In other words, this is the biggest number that you can find that will divide both these numbers evenly. Okay? So our GCF is this, and we will box it because that's our answer. Okay? Now, here's another thing too. With the x cubed and the x power 4, as you can see, we were able to group 3 of the x's, right, out of the 4 in the second part. But we grouped all 3, we found all 3 of them to match with the x's in the x power 4. What this tells us is, if you would have the same base and different powers, you could simply go for the smaller power. Okay, the lowest power will give you the GCF. So as you can see, the lowest power was x cubed. So in future, you do not have to expand the x as many times. Okay? So what I mean is, if I had y power 7 and y power 2, the GCF, or the greatest common factor between these two, would be y power 2, because you will always choose the lowest power, because that's going to fit in 7, right? But 7 is too big to fit inside 2. That's how you understand this. So the power 2 is going to be common to both the y power 7 and the y power 2. Okay? Likewise, if you had m power 5 and m power 4, then you're going to choose m power 4 as your GCF, because that's the lower of the two powers, and 4 will fit in 5 and will fit within itself. Right? Let's look at another one. Eventually, you will be able to find the factors right away. Like, for example, 4, you don't really have to do the tree for this, right? The tree breakdown of factors. 4 will break up as 2 times 2. And we also do not want to split the powers for the letters, for the variables, because we're going to choose the lower power. 6xy cubed. 6 is going to be 2 times 3, x, y cubed, right? So I'm going to collect the common ones. The 2's are common. But with the x squared and the x, we did not expand it, but we do know that when they have the same base, we go for the lower power. The power here is 1 because we don't see it written explicitly. The power is 1. So we choose the lower power. So this would be for the x's. Then go for the y's. For the y's, you again have y power 1 here, which we don't see, but it's a 1. The y cubed. So clearly, the y power 1 with the lower power would be your GCF between the y's. So now go ahead and collect your GCF. 1, 2. 1 for the set of 2's that you found common, x power 1, y power 1, which is simply 2xy. That's your GCF. Okay. So again, if there are larger numbers, you can use the tree by the side to split it up, and always multiply them out to see if they give you back the number that you began to split. And then for the variables and their powers, match the same base ones and then see which one is lower and collect them. Now, if you had anything else that was not common, you cannot choose them. For instance, if I had one more variable, let's say, I'll use a different color. Let's say we had a z, but there was no z here in the 6xy cubed. Then you do not have any common one, so you will not choose the z because it didn't have anything common. It's only if the x's were common, the y's were common, and the z's were common that you would pull one for the z. Okay, I'll just remove this, but I want you to understand that only for common variables will you even consider the lower power. Next, we move to factoring. Okay, so when we factor this, we are given a polynomial and we need to factor out the GCF. So when you see this language factor, it means to pull out. Factor means to pull out the GCF. Factor, the word factor itself means the numbers that are being multiplied together, right? As we saw in the previous case, we use the tree method to split the given number into its factors. So the word factor means to break it down. But here, when the instruction says factor, it basically means to factor out the GCF. So pull out the GCF. All right. So being the first problem, we will just look at each term one by one. So 4x would be 2 times 2 times x. And 12 would be, again, if you want, you can do it by the side. If it's 4 and 3, 4 splits up as 2 and 2. And your prime factors are 2, 2, and 3. So let's write that here. 2 times 2 times 3. There was no x here, so x is not common. So we will not use x in our GCF. So your GCF would be from grouping common ones. One set of 2, another set of 2. So 2 times 2, which is 4. Okay, your GCF is 4. Previously, we stopped right here. We said GCF is 4. But here you are not given two separate terms. You are given one polynomial, 4x plus 12. There is a plus in between that combines those two terms. So this is what you need to pull out from each term. To pull out means to divide out. Divide out. Okay. So divide out the 4 from the 4x, divide out a 4 from the 12. So let me show that to you here. So 4 is to be pulled out. Okay. It needs to be pulled out from the 4x plus the 12, right? That was given to us. So to pull out means to divide out. So please remember to divide out by this 4 that you're pulling out. Okay. So what you get is, again, cross cancel them. So collect what is remaining. So but after dividing out each term by the GCF, you get x plus 3. Okay. So dividing out is a nice way to understand this. Some of you would like to see it simply as, you know, the way it's being multiplied. Okay. So we have 4x plus 12. That's our question, 4x plus 12. We pulled out a 4. So I have to fill in for what is remaining inside the parentheses, right? I pulled out a 4 from the 4x. So what is remaining? We have just the x. So if you multiplied the 4 and the x, you should get back that 4x from the problem. Then you see a plus, so you put a plus in between. And then 4 times what will give me a 12? That's the next question. 4 times what will give me a 12? 4 times 3 will give me a 12, thus arriving at the same answer. So it is the same concept. You either see it as dividing, like what I've shown in the first part, or you see it as multiplying, asking yourself, the pulled out factor times what will give me the term that was originally presented in the problem. So it is totally your call, but you can choose to view it either ways. Okay. And anyway, this was our answer. I'll box the answer. You got the same answer the other side too. It's enough to box one of them because I was just discussing two different ways of doing the same problem. Let's look at this one. Now we have 3 terms. Is it okay to find the greatest common factor? Absolutely. So we will take each term separately. Again, eventually you'll get a handle of all these things and you'll be able to do them directly, right? For that, you need to look at many problems so that you get used to the different ways they appear. All right, so we have 2 times 2 times y squared. 24y. 24, we did that previously, right? We got 2 times 2 times 2 times a 3 times y. And then 28. 28 is, again, you could do it right here. 28 is 7 and 4. 7 is already prime, so 4 can be split as 2 and 2. So 2 times 2 times 7 is what we have. There was no y in it, so y is not common to all three. So we now find the GCF by grouping what's common to all three. One set of 2 is common to all of them. Another set of 2 is common to all of them. The others, they are not common to all of them. Y's are common for just 2 of them, but it's not sufficient. You want it for all 3. So our GCF is 2 times 2. Again, you count it only once for that set. For one grouping, you count it only once. So your GCF is 4. So here I'm going to pull out, let's see. Let me clear room here and do the GCF here. So I'm pulling out the GCF. So 4 is pulled out, right? So I have 4y squared plus 24y plus 28, which is given in the problem, but I have to divide out the GCF. So I divide by the 4 everywhere. 4 times 1 is 4. 4 times 1 and 4 times 6 is 24. 4 times 1 and 4 times 7 is 28. For those of you who'd like to see it as 4 times what will give me 4y squared, you will still arrive at the same answer. So 4 times y squared plus 4 times 6y will give me 24y plus 4 times the 7 that's left over will give me 28. So you will still get the same set of answers and set of terms. And box your answer. Next, we factor by grouping. Okay. Now, what happens if you had 4 terms? Okay. Well, you could see if there's anything common in all of them, in all the 4 terms, and pull them out. That's one way to do it. Mostly, that's the first step that we do. We always see if there is any common factor. Do you see anything that's common here? No. First of all, we understand that the first term, xy, does not have any number. So that itself tells us that no matter what we have in the other terms, even if they are common to the other ones, it still is not common to all 4 of them. So no number is common to all of them. Then look at the letters. The variable x is not common to all of them. It's not found in every term. So x is ruled out. The other variable y is not common for all of the terms. Again, that's ruled out. Therefore, you don't have one single GCF for all of them, right? In other words, your GCF is just a 1, because 1 is what is common to all of them. So if that's the case, then it seems as if you cannot really factor this out, right? But the instruction says to factor. So we will resort to grouping. Okay, as the name says, grouping means you need at least 2 to group. We have 4 terms, so we're going to choose to group them 2 by 2. Okay. So we will group the first 2 together and group the next 2 together. And within this group, let's see if there is any common factor, GCF. So between these 2, the numbers are not common, right? You have a 1 here. You don't see a 1, but you know that's a 1 in front of xy. So there's a 1 here and there's a 3 here. So no number is common. Let's look at the letters. What's common to both of them? The letter y. So y is common to both of them. So I will keep the y and write what is remaining. I pulled out a y, meaning I divided out a y. So I'm left with just an x here. In the second term, I pulled out a y, meaning I divided out a y. So y's cancel off. You're left with just a 3. Okay. So you see what is remaining and collect them. And then let's move. There's a plus in between them, so go ahead and write the plus. Then between the next 2 set of terms, what's common between them is 2, right? If you split up the 6, you get 2 and 3. So 2 is common to both of them. Pull out the 2, and then you collect what is remaining. So you have the x here. So if you divide a 2 out of the 6, What do we have? That's the question. Or in other words, 2 times what will give me 6? 2 times 3 will give me 6, right? Okay. What's interesting is right now you have 2 factors, the 2 things that are being multiplied, the y and the x plus 3, the 2 and the x plus 3. As you can see, the x plus 3 is a factor. Even though you see a plus there, you know that they are grouped together because of the parentheses. The parentheses kind of sees them as one group. So x plus 3 is one group. That one group is common in both the terms. X plus 3 is common in both the terms. So you will factor out x plus 3 itself because you don't see it as 2 separate terms. You see it as a single factor, a single group. So you pull out the x plus 3 from the first one. What are we left with? If you divide out the x plus 3, you're simply left with the y. And in the second term, you pulled out the x plus 3, which means you're simply left with a 2. And that is your answer because you really can't go any further. You're left with 2 factors, 2 groups. One group is x plus 3, one factor. The other factor is y plus 2 itself together. You know they are together because of the parentheses. Okay, so that is the end of our lecture here. I hope you enjoyed it. I will see you in the next one.